So thanks for joining this talk, or the title of this talk is Vehicle Security Trends, Implications for the Auto Supplier. Start with a brief intro of myself. My name is GUZMAN. I'm based out in Los Angeles. I head up an automotive and IoT testing team for a company called Aon. I lead the OWASP IoT project and the Embedded Application Security project. I'll be talking about those projects at 11:55 in Project Showcase. So if you want to hear about some updates and things that we're working on, I think it's Hall G. A couple of things as far as background within automotive space and IoT. I've helped facilitated the Automotive ISAC's first tabletop exercise about 2 years ago down in Honda in Los Angeles, which is an experience with several of the OEM manufacturers as well as tier one suppliers, basically going through a mock of an incident and how they would respond. If you've ever interacted with anyone from the automotive space, they don't like to really collaborate too much, so it was definitely 8 hours of pulling teeth. Outside from that, I published the book, IoT Penetration Testing Cookbook, in November of 2017, and also edited a few IoT security books with Packet Publishing. Outside of that, I love pizza. I am disappointed that I packed pizza socks, but I packed 2 different pizza socks, so I decided to leave them back in my room. So outside of that, have disclosed some security research for automotive and IoT products, specifically for Subaru. Was able to compromise a Subaru vehicle, add users to the account, basically the essential functions of Starlink, Subaru Starlink on unlocking cars and honking horn, flashing lights, things like that. Had some fun. That was a couple years ago now. So enough about me. I'll go through a brief agenda here. We're going to talk about some advancements in the automotive space, talk about suppliers and their development lifecycle, go through some research case studies, also some field work that we've performed and got hired for suppliers and manufacturers as well, and go through some solutions, mitigative solutions, and then if we have time, we'll go through questions. So there's some major trends going on here within the automotive space. One is electrification. The other is mobility as a service, autonomy, self-driving vehicles, and connectivity, all of which are kind of in a way dependent on each other. Essentially what the automotive industry is doing is not only becoming a product, but also technology a company filled with services in the way of integrating with not only the vehicle itself, but also third parties, and we'll get to some of those concerns in a bit. But in order for full autonomy, full self-driving cars, you'll have to have full connectivity, perhaps electrification moving forward as well. The majority of newer vehicles already have some of this functionality as far as connectivity, autonomy, and we'll go through some of the levels in a sec. But essentially, this is what's going on as far as new developments. And I guess first we'll touch upon connectivity and what's happening in the connectivity space for automotive. Usually, in order to connect a vehicle, you'll have either telematics control unit or board. And usually you'll have some sort of network connection via LTE. You could even have it via Wi-Fi. Moving forward, maybe we'll see some 5G, and then we'll really have some autonomous vehicles going out. So with connectivity, we have these new kind of alphabet soup acronyms. You have vehicle to infrastructure, where your car is talking to the infrastructure, vehicle to vehicle, vehicle to pedestrian, vehicle to device, vehicle to grid, and vehicle to everything. Again, these are all requirements for connectivity and vehicles moving forward. Again, vehicle to vehicle is just basically exchanging, certain information about traffic, about distance, some metadata. Vehicle to infrastructure similar kind of architecture, except talking to basically infrastructure for roadside units and intelligent traffic systems in the future. So a lot of exciting things going on, but certainly, obviously, expands the attack surface from a security perspective. With all these acronyms and connectivity requirements, you also have new companies and suppliers who are developing software outside of the traditional OEM manufacturers. So some of these demands, in order for connectivity to actually work, you need the vehicle to be cloud connected 24/7, ability to perform secure over-the-air updates, not only for the vehicle itself, but also components. And we're seeing this with safety critical components with Tesla, which is a little scary. We now have basically DevOps in vehicles now. It's kind of cool, but kind of scary. Also, similarly with IVI applications, so the head unit applications, now, I guess being pushed down from the manufacturers, they'll want updates to be on the fly. So updates to your head unit applications are also coming down in the future, if not already. I believe some manufacturers already have that in place. And with connectivity, you have more data that's being shared not only with the manufacturers, suppliers, and the infrastructure in cities, but also third-party services in order to, whatever may be for licensing, which is basically selling that data. Another word that's been kind of coined in the industry. They don't like to say, we're selling your data. They like to say we're licensing your data. And of course, not only with being connected all the time, 24/7, not only with secure updates, but also they want reliable connections. They want resiliency, some redundancy, and obviously security, meaning going through secure channels, whether that's end-to-end encryption or using other means, hopefully not through proprietary protocols, which are being debunked now. So with connectivity, we talked about autonomy. ADAS is also an acronym used, but essentially there's 5 levels of autonomy. We're currently around level 2 here, which is the driver assist, the pro pilot assist, the lane departure assistance. There are vehicles that are said to be level 3. I think one of the newer Audi R8s. But there's some gray areas here with level 3, meaning if the vehicle is driving and there's a driver behind the wheel or a vehicle operator, they're supposed to be ready to intervene at any time. But chances are, if your car's already self-driving, you're not going to be engaged. It's going to be very difficult, at least to be ready, especially if the vehicle isn't planning for certain situations. So every manufacturer already has a level 2, a level 2 autonomy in their model years. The Fords, the GMs, the Subarus, the Toyotas. I think after 2017 and up is when every vehicle is already equipped with telematics units. So installed, whether you are a subscriber or not. So you got to think about that. Unless you take out that telematics unit. But it's said that we'll have full autonomy within the next 10 years, if not sooner. I think there is a huge dependence upon 5G. So some real scary situations, but essentially there's self-driving trucks already in the field. So it's also causing disruption for the economy. So just be mindful of some of these levels here, and we'll get to some of the concerns in a second here. But essentially, drivers are fading away and now becoming vehicle operators. And they're even hiring for vehicle operators, which is crazy. So quick graph here from Edmund showing the active safety features, basically when the vehicle is taking control of something that will cause safety concerns. which is adaptive cruise, blind spot detection, lane departure. And you can see on the rise, essentially, again, this is only 2017. Pretty much, we're probably in the 80 to 90% percentile for active safety features with newer cars. But what's scary is that we're giving up our trust to someone else's code or several thousand people's code who are writing the software, to keep you safe, to keep you happy, convenient. There's even aftermarket autonomy, meaning devices that you can install on your vehicle, cameras, aftermarket, basically wheels that will, again, do some self-driving functions for you, which is really, really sketchy. But I wanted to share a specific quote here from there's a company called Lane Cruise, and basically they're retrofitting vehicles, not only to be connected, but again, have these autonomous features. So I was scrolling through their page and going through the FAQ, and they have, at present in most jurisdictions, level 2 autonomy is not regulated and hence totally legal. This is why you can buy a luxury car with some of these features built in without any legal implications. So right away, I mean, that's some red flags. And this is just, again, an aftermarket, this is an aftermarket company that's developing software. People are using this in their vehicles already. Super, super scary. I couldn't imagine, this Lane Cruise company, even if it has several hundred employees or developers, I'm sure that there are some flaws, several different types of flaws, but just the thought of this code being introduced into vehicles, expanding that, older type of vehicle, this El Camino, for example, a 90s, 80s car that's now going to have self-driving capabilities. So, given the example of the startup company, Lane Cruise, you're probably wondering, who's building and innovating in this space? Like, who's responsible for developing the software? And it's just a sea of partnerships, acquisitions, and newer types of OEMs who are building self-driving vehicles from the ground up and fleets. So essentially, loads of Silicon Valley startups who, are proposing perhaps Lane Cruise might be acquired by, a manufacturer at some point. But what's happening is OEMs are essentially turning into, venture capitalists, angel investors, acquiring these companies, partnering with these companies, and then working with tier 1 suppliers. And this graph is purely just the relationships in 2017 for autonomous vehicles and who's partnering with who. So essentially, everyone's partnering with someone or perhaps the same supplier. And what a supplier is, well, we'll get to it in a second. So essentially, again, third-party companies who are developing the software. It's not the OEM manufacturers who are developing all the software, the head units, the in-vehicle networks. There's a lot of third parties involved. So the supplier types and roles. If you ever open up the hood of your car, you'll see several different names of the product manufacturers. So you'll have the hardware components, which have the body control modules, powertrain sensors, your gateways, cryptographic modules, and so forth. But you also have the software components, which is the platform operating system. It could be a QNX, it could be AutoSAR that's being used, it could be an older Microsoft. But also there are third-party suppliers who develop drivers and libraries to help connect certain areas of the hardware from the software perspective. And then also the suppliers who develop the IVI applications, the mobile applications, the web applications. It's not these manufacturers who are developing the software. They're partnering with the supplier, a third party essentially, in order for this to happen, to be pushed out. So a lot of moving parts, right? A lot of cooks in the kitchen just for one product. And this is similar not only for automotive, but IoT as a whole. Anything really product or embedded related essentially has a similar structure of supply chain and development. But what's, I don't want to fearmonger here, but just kind of gain a perspective. The amount of code that's in a vehicle ranges from 100 to 300 million lines of code. And this is not only just the in-vehicle networks, but also the head units and several other aspects of a vehicle. There's 40,000 hardware parts, and this data was taken from Toyota. So this is Toyota's estimates. And think about that there's code and hardware and software and wireless protocols. Essentially, code is everywhere. And folks like us and OWASP are here to help try to gain insider perspective, not only from an attacker, but also for secure coding. We reviewed an IVI application, one application that's a default application on several vehicles, and it was 6 million lines of code just for a head unit application. This is the client side and server side code, which is crazy. 6 million lines of code, it's absurd. And there's only going to be more code being introduced moving forward, with all the connectivity requirements, the V2V, V2I, autonomy. So difficult to try and guarantee safety and security with that much code, and especially legacy code and code that perhaps a supplier is developing for not only one manufacturer, but let's say 4 manufacturers. So again, everything is code. So this is just an observation here based upon some of the assessments that we've done. So we've not only done penetration testing assessments, but also maturity reviews for suppliers. And this could be even a supplier coming to us, and they're partnering with a third-party company, let's say in India, and they want us to review if their SDLC if they're saying that they're testing, they're doing source code analysis, dynamic, and so forth. They call us in to verify, kind of do align with like OpenSAM, for example, a software assurance maturity model. So we've been engaged with multiple suppliers who are publicly traded companies who have over 300 developers and 0 to 3 cybersecurity professionals, which is amazing to me. And some of the requirements, the job posting requirements, they'll want 5 to 7 years in security. They want some engineering experience. Basically, they're asking for the world here, but yet they have no one internally to even interpret, let's say, their source code analysis output, reports and so forth. So if you look through a number of different suppliers' career pages, they're pretty entertaining. But again, shocking that, I guess not super shocking, but that the lack of security within a safety critical area or critical infrastructure now, moving forward with vehicles, isn't getting much love. But hopefully that'll change moving forward. I know several manufacturers now have internal red teams, which wasn't a thing before. I think in the last 3 years, I think the majority of manufacturers do, aside from some Japanese manufacturers. Won't call them out, but to run through the software development supply chain here, essentially you'll start with the OEM who defines the specifications for what they need, what they want, whatever it may be for either a telematics control unit, a head unit, a body control module. But essentially, you'll start with the hardware requirements. You'll have your board support package that could be working with a driver, a company like Broadcom or whoever else, Bosch, whoever it could be. You have your downstream suppliers, your software suppliers, essentially people who are developing the code. Your cloud providers, whether it's AWS, whether it's Azure, whether it's their own in-house cloud. And then you have integrators who work with these suppliers in order to kind of ease that that transition to a production environment. So then you have, several third parties, several different teams involved from around the world. And then for me, looking at kind of the overall process And from the handoffs from team to team, there are several flaws that you can obviously identify, but a number of different third-party code and teams to be targeted. Super simple. We could easily target an open source library or a software supplier in any of these stages, in order to get, not only affect, again, I mentioned one OEM manufacturer, but several. So a lot going on. Again, very, very similar landscape for IoT devices as well, aside from the integrators. But just imagine this area here branched off into maybe 20 other different suppliers. So not only are, we're having legitimate software suppliers via, tier 1, tier 2, tier 3, but now they're expanding this supply chain with third-party development services and, basically, essentially having cryptocurrency in your vehicle now. How amazing is that, or not? Jaguar just released a program where you'll have a smart wallet in your vehicle that basically it'll report the potholes and flaws in the road. So essentially, you're getting paid automatically for your vehicle, and also pay using your car for services, whether it's gas or going for a coffee of some sort. So these services, again, are a little bit, makes me a little bit nervous. Again, having cryptocurrency here, earn cryptocurrency for your vehicles. And other manufacturers are also following the same trend. Honda just released their mobile wallet out in CES this past year. Again, integrating with third-party services and the infrastructure of the services being offered by gas stations and restaurants and so forth. GM has its own marketplace. You can order, again, Starbucks, get some donuts. My personal favorite is Applebee's. There's no Applebee's here, but one of my favorites. So this app marketplace, think of it like an Android Play Store, where essentially previously legacy apps, where you didn't have much to choose from. It was just whatever is default and maybe a few others that you can install. But now you have the opportunity to pull down the apps from a marketplace and do some reverse engineering, disassembling, and so forth. With the apps in the marketplace, or you can just develop your own third-party app using, their developers program. They supply you with an SDK. They supply you with emulators. They supply you with everything you essentially need to get off the ground. So you have folks like you and I who can develop software for your cars. And some of the level of access that these SDKs have are access to the internal vehicle networks. So you can scrape CAN bus, you can scrape maybe a media network, whatever you want, essentially. So really scary from that perspective. Again, opening up that traditional kind of closed off, no network environment, no apps that probably never get updated on your head unit, to a more dynamic landscape and more open with third-party developers, and they'll have minimal vetting for developing software and becoming a partner or a supplier. But anyone who is motivated or has an end goal for compromising a vehicle can easily do it via their third-party developer portals. Other services like Amazon's Key in Car with Ford and Lincoln basically unlock your car for Amazon delivery drivers. So again, not only are you trusting strangers to enter your vehicle, but we also talked about the adaptive safety features for your car, the lane departures and so forth. This is a massive target, right? And it's easy to put some attention here, just because, again, the many different hands, many different teams, many different services, and it's only going to increase moving forward. And this is already happening, again, in IoT. Anybody here heard of Mirai? So it affected the U.S., but also other countries around the world. But it took down the internet for a period of time, a couple of years back. And essentially, what happened was attackers targeted a certain original design manufacturer, ODM, which is another word for supplier. There's all these different same terms for different industry verticals, but an ODM is essentially a supplier. So they targeted Zhongmai, and Zhongmai basically created essentially the embedded Linux platform that then was built upon for custom resellers or custom OEM manufacturers to use. And there were default telnet credentials and command injections and so forth. But not only Zhongmai, you also have Blueborn, you have Crack, you have Meltdown Spectre, which are all third-party software that's installed in safety-critical functions in a vehicle and even IoT devices. And there's more examples, but it's already happening. Also, something to keep in mind is the difficulty of updating these devices. So not only in IoT, but also in just general software. There's nation state, or even malicious groups out there who are targeting the supply chain. I believe there's even a talk on supply chain today as well, probably more towards JavaScript because that's also a mess. But essentially, we have these groups here focusing on installing or actually developing backdoors and injecting those into, let's say like ASUS, for example, who was affected by this group, as well as CCleaner, where there was backdoors and basically compromising one of the suppliers in order to gain full control, remote code execution. And this is just not too long ago. So I did talk a little bit about updating or lack thereof, but essentially a vehicle has a life cycle of, or a lifespan of 7 to 15 years. A traditional vehicle, and this is changing moving forward, but a vehicle could be vulnerable for a long period of time or may not ever be updated. Maybe there isn't an over-the-air update solution for certain model years, which has happened for several manufacturers. Well, they'll send a USB stick for you to install and update. Won't speak in that in detail, but probably better solutions. So again, you have all this third-party code, applications and services that can potentially can leave you vulnerable for an extended period of time. So some case studies here that's happened within the last year and a half. There was some work done by a research firm or security firm where they shopped around for vehicles to remotely exploit flaws. And what they chose were vehicles that had a large attack surface. That being the Volkswagen Golf and Audi, they essentially use the same head unit. Again, because the same supplier, they're also part of the same company. But they discovered some vulnerabilities within the Wi-Fi hotspot and essentially gained remote code execution in several different ways. One of them was via a service in Telnet, as well as gaining access to a certain area of the vehicle where you can send arbitrary CAN messages to the CAN bus. But what they did was they stopped there. They didn't release technical details because those vehicles do not have update functionality, and they felt that they would leave those vehicles at risk. And some of the suppliers there to note is BlackBerry QNX and NVIDIA. And here's the head unit. They got root on the head unit. QNX Neutrino is a common operating system or platform used for head units. Probably there's Automotive grade Linux and QNX are probably the major platforms that are being used today. But essentially, manufacturers are partnering with BlackBerry in order for them to provide that platform security and updates. In order to keep the head unit as well as the safety of a vehicle kind of in order. So there was some research with BMW last year as well by Tencent Labs, who absolutely tore these BMWs apart. Several different models were affected. But essentially what they did was exploit multiple QNX systems that were used by the head unit and obtained, again, remote code execution after fuzzing not only the browser, not only the telematics control unit, but even the USB interface had USB to Ethernet. So again, they had two QNX systems. They had third-party Bluetooth stack, a custom browser by Harman. Again, another supplier, and then the telematic communication box was also another supplier and third-party. So I won't spend too much time on this research because I want to get into more details from some of the field work that we've performed. But just again, to show some examples and case studies of research firms or even attackers focusing in on suppliers, and again, how that affects not only multiple vehicles for the same manufacturer, but also a number of different manufacturers. In this case, there was the Tesla key fob research. Anybody heard about this? Sweet. Cool, yeah, so there was the Tesla Model S essentially was using a Pectron key fob system where the research company was able to defeat some of the wireless encryption here, and they were able to generate key codes and essentially obtain a vehicle, steal a vehicle indefinitely, not just the previous security research of obtaining key codes, a number of them to start, open up the car, stop, and potentially start again. Now they created, or had the capability using, I think $500 worth of hardware, using a Yardstick 1, Proxmark, Raspberry Pi, Rainbow Tables. Proxmark's already like $300 or $400, so probably $1,000. But essentially it's possible. And this same key fob system was used in McLarens, which are really expensive cars, as well as motorcycles, Triumph. It's really interesting to think about, as an attacker, right? You want the highest impact and something that'll get the company's attention. And again, focusing in on a supplier is definitely the route to go. So some field work that we performed, give an example here for an IVI application, or we perform multiple IVI application assessments. And this was a default application that's installed on several vehicles. The platform, it wasn't only the default application on the IVI, but it also had a companion mobile app. So some of these have hybrid environments where it's connected to a vehicle, has some functionality and perhaps shares some internet connectivity through a mobile device. But in this case, or one of the cases here, was 6 million lines of code, again, for the client side and server side code base. It was very difficult to get all the code from the supplier in order to compile, in order for us to do proper source code analysis. They didn't really know all the third-party libraries that they had. So for us, that was already a light bulb that we're going to find some pretty big issues, during the assessment. So this assessment was a gray box. So we had not only the source code, access to the developers, but also performed dynamic testing. Very, very helpful, probably the most effective way to do security assessments. But what we found was loads and loads of dead code, unused code, commented code with API keys, with essentially user account credentials, database passwords, hard-coded, not only the credentials, but the API endpoints, which gave us an easy way to get access to the admin interfaces of these applications. I'll get to that in a second. And again, in this case, what they were doing is licensing data scraped from the CAN bus. And I'm not sure if they had these agreements with the OEMs. I think they just have the access, and they're like, hey, yeah, we're going to do what we want because we have access. So these IVI applications are not only talking to the OEM's cloud infrastructure. Some OEMs require end-to-end encryption, but it's also talking to their own cloud infrastructure, third-party cloud. And you can imagine this is only one application in this case. And again, that data being shared in multiple layers, multiple services, multiple companies. But with identifying some of the hard-coded application servers on server-side infrastructure, these application servers did not even have authentication. We were able to get remote code execution on these servers. We were able to upload our own application servers. Some of the pages that we found were status pages that have the ability to dump memory from the application servers. So essentially the basics of security, security principles and cleanliness were not there. What they heavily depended on was the OEM to go and do their own security assessment for their application. But essentially, it's like a unit test where it's a bunch of checkboxes, and if the features are what they agreed upon, then that's like the bare minimum. If they require TLS, that's all they're going to put is TLS. They're not going to ensure that they're doing output encoding, and they're not going to do some input validation. It's really, really interesting case. But once the application was running, it was even logging the API keys, the user basic coordinates, the data from the CAN bus that it was scraping. Essentially everything it could, it was logged to the console. In this case, we're using a head unit that was Android-based, so Logcat. Super, super simple to acquire that data. And if you've ever, I don't know if has anyone done forensics on an automotive telematics unit or a head unit? Loads of data. I better speed up here. Loads of data there. Here's an example. This is what they were doing. Again, logging the API key, secret, request paths, all to the console, doing basically dynamic arbitrary code formation here in Java using actually C and C++. Encrypting, logging, again, the VIN and all the kind of safety critical functions as well, and even logging usernames and passwords. So really, really basic things that there was just, wasn't on top of their heads. Longitude, latitude. Here's that application server with the threads here. You can click on any of these, dump the memory, see what's going on with what vehicle around the world, because this supplier not only developed software for the US, but also Canada, China, South America. Again, this had no authentication. And here's the application server that had default credentials, of course, and a legacy Apache Access server where we were able to get code execution. So, very little effort, unfortunately. And what we did was we used standard methodologies and tool sets. There wasn't anything crazy that we did out of the ordinary. We leveraged the application security verification standard, the mobile one as well, the OWASP top 10s, not only for the web, but mobile and IoT. We did source code analysis using commercial and free tools, listed a few tools that we used. Mobile Security Framework, which is a great tool if anyone's used it before. But what was really the key was manually reviewing the code and working with the dev teams. All the dead and commented out code is not going to be flagged too much by tools. It's going to be informational at best. So in those comments, we also found GitHub credentials. Crazy stuff. So we also do product assessments for fleet management companies. There's tier 1 suppliers that essentially develop products that plug into commercial trucks and passenger vehicles as well via OBD2. In this case, it wasn't as simple. It didn't have much of an attack surface. It was using a bare metal. There wasn't an embedded Linux or real-time operating system. But we got lucky, and by sniffing hardware communication via serial, we were able to obtain firmware over the air credentials and pull over 7,000 vehicle details about maintenance, about the drivers, about essentially critical details for this commercial company, tier 1 supplier. But again, this is also retrofitting cars that aren't made to be connected. And again, you're exposing all that data now by pulling that data, and then not only for managing fleets and monitoring driver riskiness in this case, but licensing as well. For case number 2 here, for a fleet management supplier, in this case, it was an IoT gateway. And we did multiple of these, where it had Wi-Fi, Bluetooth, LTE, has cameras, and basically drivers connect to the hotspot, and the sensors around the vehicle connect to the hotspot. And we were able to obtain code execution by having a live serial connection, but essentially what we did was expose or exploit open source components. It was using Fastboot, which is an Android-based bootloader, and it had debug functionality to stack trace. We were able to get code execution by essentially using ARM assembly to then give us shell access by putting in our SSH credentials. Okay, let me close it out. Just some example code here that we used. Essentially, the bin sh here is what we used to get code execution. Mounted the file systems, able to input our user, and then get root at the end of the day. Another finding, we were able to bypass secure boot by using a malicious NTP server, pushing down to an expiry date that wouldn't be recognized. We found that this is a problem with all embedded devices, essentially finding a trusted source of time. Interesting problem. Let me run through these really quick. I know we're out of time. Again, the suppliers are reliant upon OEMs to perform security initiatives and testing. There's a lack of security culture, personnel, and folks who understand security within supplier companies. So especially when you have these startups and newer types of products that are being developed by Silicon Valley companies. And essentially writing software that had not been exposed to the internet previously. Again, we talk about these client-side credentials and secrets that would not normally be internet-facing and now is. And lack of transparency through the supply chain. Essentially, black box binaries are given to OEM manufacturers and that are being compiled into their head units or whatever the product may be. Their suppliers essentially have their own suppliers. So this kind of trickles down. Think about kind of the JavaScript supply chain issues. So we'll wrap up with some technical guidance here, or at least some mitigation measures. There are several different best practices to bolster up security programs for automotive companies. There's a new standard being released in 2020. It's an ISO standard that's going to work with OEMs and Tier 1 suppliers, which is promising. Essentially, it's going to show their due diligence for security, which right now it's a mess. There isn't a standard for cybersecurity in the automotive space. So everyone's using their own frameworks, which you can imagine is like developing your own crypto. Okay, guys. Just need to wrap up. If you have any questions, feel free to find me. I'll be in the project showcase. And thank you for your time. Appreciate it.